already lost in step 2. Okay. The moment I'm looking at it, I'm lost because maybe because my intent is not to really explain this slide, right? But the idea is there's a second way of doing it. Okay. Now this is apparently how they do it in middle school. Okay, at least in US. Okay, find the prime factorization of m. You know what prime numbers are, right? Any number that is divisible by itself or by 2, I think is a prime number. Something like that, right? I think 2 is a prime number too, right? By the definition. So there are so he's doing some kind of factorization. And then if you compute the product of all the prime factors, that will be the greatest common divisor of m and n. The question is that an algorithm or not? In this particular case, what do you think? I can see some of you are able to at least put it in chat. Why don't you put it in chat? Is this an algorithm or is this not an algorithm? JNTUV, I know you're putting something in chat. Go ahead and put something, whether this is an algorithm or not an algorithm. You can ask the students there. Aditya, you are also welcome to put something in chat, whether this is an algorithm or not. Okay, I'm assuming you are able to put. It is not an algorithm. Okay, so Chaitanya said it is not an algorithm. Okay, so I'll say, why is it not an algorithm? I hope all the other colleges are following. We are saying, is this an algorithm or not? And somebody from Chaitanya said it is not an algorithm. Why is it not an algorithm? Chaitanya, you can unmute yourself and speak, provided your audio is working with no static. Okay, they said because in step 4, there are 2 steps involved. Compute the product of all the and return it as. Okay. Okay, I want to give chance to others to express their opinion also. Somebody other than Chaitanya. Come on, JNTUV, you're always at the forefront. Somebody from JNTV type in there or speak out, unmute yourself and speak out. Faculty members are welcome to express their opinion too. It doesn't have to be only students. I'm assuming that there are a lot of faculty members there. Please do speak out. I have a big list of faculty members, right? I have Aditya. I have, okay, I'll unmute Aditya. Oh, Aditya has a lot of static, so I have to mute them for a second. Chaitanya answered. I will not let Chakravarti Garu speak yet because he knows everything, so we'll wait for him. Any faculty member or student from Indranil? I have unmuted you. Okay, so a lot of people are able to hear me. Naresh, which college are you from? I do not know, but Naresh is not able to hear me. Indranil, if you have anyone to comment on this. Okay, so Principal HM can hear me. Okay, good. Since HM, okay, JNTU MT, let me unmute. Anybody wants to answer that question from JNTU MT? Chaitanya said this is not an algorithm because in step 4 there are 2 steps. Do you agree with them or you don't agree with them? if you're not able to speak because of static or something, you can type you agree or not agree. Okay. Okay, I have to unmute. Okay. Okay, looks like you are not able to talk, so let me type it here. Does everyone agree with Chaitanya? Oh, that's a lot of static. Okay, I have muted Vasavi because I'm getting a lot of static from Vasavi. Okay, does everyone agree with Chaitanya that it is not an algorithm? If you don't agree, you put it in chat. In the meantime, I will express my opinion, okay? For the sake of argument, I will take the opposite viewpoint. Why is that not an algorithm just because it has two steps combined into one? Algorithm is just a step-by-step process, but the number of steps that I show in a solution might be a combination of many steps, right? No one told me that a step has to be atomic, right? I don't think algorithm has been defined like that. So I'm going to Chaitanya take an opposite viewpoint. I would say this is an algorithm. It has the look and feel of an algorithm. The only thing is it's probably not at a sufficient level of granularity, right? So if you take step one, for example, find the prime factorization of M. Now, what is prime factorization has not been defined, right? Then there should be an algorithm to determine what is prime factorization, right? So like it's like having an algorithm within an algorithm, right? So as long as we understand that some steps could be a collection of smaller steps, I do not foresee why it should not be an algorithm. Okay, let me move on for the sake of argument. And I want to keep track of time because in 3 minutes I have to go and then take a 15-minute break and come back. Okay, now this is a very famous thing. Even I forgot all about it till a couple of years ago when my daughter came to me. Hey, tell me what the Sieve of Eratosthenes is, right? I can't even pronounce that Greek mathematician's name. This is how they find list of primes less than or equal to n. Okay, whenever you are given some number n, how do you find the primes? Okay, so here is one algorithm. There's a for loop. There's a second for loop, right? Square root of n, and then you do some process again. I'm not interested in telling you what these gory details are here to find the prime numbers of n. Okay, but there's some kind of an algorithm. If you see here, the way they use for statements, while statements, showing some assignments. So this is all kind of like pseudo code, right? This is not like total computer programming. There is no computer programming language where if you have an arrow, that means it's an assignment statement. Okay, so you mix a combination of computer keywords and English like or mathematical symbols to show some kind of an algorithm to solve that. Okay. The question then becomes, right, why do we want to study these algorithms? Okay, somebody is trying to talk. Let me mute them. Somebody just came online. Please mute yourself. Okay, please mute yourself. Okay, great. The reason why we want to study is very important, right? It's all about performance. Okay, um, because if you have two ways of doing it, if one is a faster way of doing it, I would much rather use the faster way. Yeah. So the principal said here privately, again, put it in for the general audience. If you can do that, I will give you your next lunch will be on me. I'll reimburse you for lunch if you put it for everyone. This is what the principal underscore HM put. It's easy to understand by any user. That is very key, right? When the designers have to talk to the stakeholders, a lot of times business stakeholders today in the industry, they have become very smart. They ask, what is your solution? In the past, I used to tell them, tell me what you want, I'll figure it out and give you the solution. And it was pretty understood. They were always quiet, but now they don't agree with their answer. They say, tell me how you are going to solve it. So I have to give them a way, something like this to show them this is how we solve it because they understand this language. So it's easy to understand. Okay, what else? Why do we need to study algorithms? Many reasons, right? Because we always want to do it in such a way it's faster, as I mentioned to you. Plus, there's another aspect of it, which is the data structures part of it, right? You always want to take less amount of storage. Okay. So that way, when you're running your algorithm, it'll be faster, right? If you do a linear search for let's say I have 1,000,000 names in the database in some big table. Okay. And if I'm going from top to down, and if I'm looking for a name, it so happens the name is the very last row. You just searched you searched million rows of data, right? But if I have stored the same thing in some kind of a tree structure, our algorithm would follow something called binary search algorithm. I'll teach you about all of those things, where you cut down the search time drastically, exponentially. So there are many reasons like that. The bottom line is to increase the performance of the computation. Okay, that's why we need to study algorithms. Okay, now the course is very simple, right? Then it boils down to two things here. One is, how do you design these algorithms? I showed you 2 or 3 different ways of doing Euclidean GCD, right? So how do you come up with those designs is what we need to understand in this course. And once you design an algorithm, how do you analyze the algorithm efficiency, right? So if you go back to the Euclidean, what would be the, which one of those is most efficient is what we need to figure out. Okay. Now, in general, when you're talking about, okay, I have to look, I'm looking at time. In general, these are the various ways in which to design the algorithm, right? Brute force, divide and conquer, decrease and conquer, different terminologies, right? You analyze them based on space and time trade-offs, okay? So we look at all these things as to how we apply each of these things in different scenarios. Okay, so I'm going to break here for 15 minutes. Time now is almost 10 p.m. That is 11:30. We'll come back again at 11:45 your time. Okay. In the meantime, during the break, I want the students to tell me. Again, the break is for instructors, but I want the students to. I want the guys stop talking. Please, please mute yourself. Let me finish what I'm saying. I want the students to go back to the GCD problem. There are 2 algorithms that were given there. If you see slide 3 and slide 4, right? Which of those algorithms is efficient? So when I come back, I want the answer to which of these Euclid algorithms that I showed you is more efficient and what is the reason why it is more efficient. Okay. Look at Euclid algorithms here, 3 and 4. Let me put them in a note. Let me put it in a, let me say view. Give me a second. Let me go back here. I will say view, normal slide master. I'll say I do not know if you can see that. I will put it in slide master. Let's see if that works. No, that's not working. I'll go back to normal. So I want you to come up with your own notation as to how you will compute, right? It could be as simple as how many steps this GCD algorithm is taking. Okay. And how many steps this is taking. Okay. So take a 15 minutes. In these 15 minutes, you figure out these two. And when I come back, we'll discuss that. Okay. I'm putting myself on mute for 15 minutes. Faculty members, you are allowed to take a coffee break while I'm taking the break.
That was two algorithms. First one is Euclid algorithm for solving this tricky problem, and this is normal algorithm. And this is good, both algorithms. That is second and normal. But the problem of both elements is first one is most critical. Why? Why? In the second one, no need to find the biggest of the two numbers and not equal to 0. The extra step was needed. But for first algorithm, no need. Directly you can solve it. Observe it. Observe it. Observe it. Both the algorithms are almost same. But this first is you need to find out and then remember to that and okay. This is suppose n equal to a small number. If n equal to greater than that, it never ends. Never ends.
So what are elements n now? And the water factor is n minus elements n minus operation time complexity n minus plus last element possibility so plus here the representation of by using mathematical reduction. But if we suppose that computer is allowed to understand, and there is university master. This is pure mathematical action power in mathematical integration process. Today, you will also consider as some example relation status, find out the time complexity. Mathematical section answer to this time complexity by your data. No. For example, relation of
Okay, I am back. Okay, I have muted all, but I can see that Chakravarti Gaur has put something. Second algorithm is more efficient in terms of time complexity. In first algorithm, processor has to save the current running state when a recursive call occurs. So there is overhead. Good analysis, Andy. Chakravarti garu, thank you. I'm hoping that you are able to hear me, right? Let me see. You're ready? Yes. I'm not muted and I'm sharing my video. Okay. Chakravarti garu, I'll unmute you for a second. Okay, go ahead and talk, Andy. I want to see if others can hear you well. Can you explain what you just said one more time? In the meantime, I'll share my PowerPoint.
Good morning, sir.
Cheppandi.
In second algorithm is more efficient than first algorithm, sir.
Okay, tell it to the class. But first tell your name.
My name is Vivek.
Okay, Vivek, tell me why second is more efficient than the first.
In first algorithm, whenever a recursive call occurs, the processor has to save the current running state of that procedure and it again starts executing the recursive call.
Okay,
So
and where that's good, that's excellent. Where is it saving all that?
it's in a stack.
Correct. So students from other colleges, are you following what Vivek is saying? You must have learned about stack and all that in one of the computer architecture classes, right? Or operating systems class.
Yes, sir.
Correct. Okay, good. That's good analysis.
Thank you, sir.
Now, okay, now let me ask you a slightly different question. Okay, someone else answer. Now, I'm a computer science professor. I understand compilers, operating systems, stacks, and all that stuff. So whatever he told me makes sense. Now imagine you have to explain this to a business owner who asks you to develop a solution for him. Okay, how would you explain it to business owner that one algorithm is better over the other one? Is there a way you can explain it in simpler terms to a business user? The question is open for everyone, including faculty members. The question is, how would you explain what Vivek explained to a business user in language that they can understand? Is it possible? Somebody is getting up to come front to take it or take another seat, or they are trying to explain it.
Good morning, sir.
Good morning. Tell me your name, man.
My name is Gopal Krishna, sir.
Tell me.
Okay. To a business person, simply we can say, if we prefer a second algorithm, then it will be more profitable to us because it takes less time.
Okay. It'll be more profitable because
Yes.
it takes less time. Okay, that's one way of explaining, right? So if he asks you, how would it take less time? How would you say?
Because
Tell
it
me.
is efficient algorithm.
Okay, it is efficient because it takes less time.
Yes, sir.
Okay, that's a pretty good explanation. Okay. If they still insist, then you have to get into more detail, right?
Yes, sir.
So can you get into more detail, such as saying that, hey, this other one will take 15 steps?
Yes, sir. Because if we say that the algorithm takes less number of steps, then business person will understand, sir, that
Exactly. Got it. So you should be able to go comfortably between the technical way of explaining versus the business way of explaining, right? Good. Today,
Thank you, sir.
Chakravarti garu, today your students are on a roll there. I'm encouraged. Okay, good one. Chakravarti garu understands my statement, why I said that. Okay. I'm assuming that rest of the participants understood too. Okay, so whenever we design something, we should be able to analyze it from an efficiency viewpoint, time efficiency and storage efficiency. Okay, it's fun, right, to come up with algorithms. I was just thinking about algorithms in real life. You all, the young college students, understand this, right? How many of you have seen the movie Srimantudu? Show of hands there, Jntuk Kakinada. అందరూ మహేష్ బాబు ఫ్యాన్స్ అనుకుంటా. Or maybe the boys are Shruti Hassan fans. No? We all like Mahesh Babu here in USA, by the way. We think he rocks. Hmm? Okay, so he had a nice algorithm there, right? He wanted to go after Shruti Hassan. What was the algorithm that he applied? Every aspect of human life, you have algorithms, believe me. So he has a very nice algorithm, right? He went and enrolled in the classes that she takes. That was a fairly efficient way of doing it, right? Okay, so much for Mahesh Babu. Any questions from other colleges? If somebody has questions on what I just described, just put it in chat and I'll be happy to answer them, okay? Okay, let me go back to some slides here. By the way, Vivek and your friend, you both explained it better than I would. Good job. Well done. Okay, now let's see. We finished that. We finished this one. Okay, so we said there are different techniques of coming up, right? There's no hard and fast rule, guys. All said and done, algorithms and solutions and all that, it is more science than, more art than science, right? And as we talked about in terms of efficiency, we always talk about time efficiency and space efficiency. We have an important visitor here. If you see a young lady there, that's my daughter. Say hi, Kirti. Where she gave the Einstein quote today. Okay. So I'm used to having my daughters accompany me to lectures. Okay. So they used to accompany me to lectures when they were 2.5 years old too. Okay. And you'll all like her because she's the one who tells me be nice to students, make sure you give them all A grades. So, okay. Now, so that is one thing. The other thing that you need to know is, right, what are the problem types? Ultimately, I mean, I remember when I was a graduate student, we used to argue, right? I can boil down all problems to sorting, searching, some string processing, graph problems, we'll see what combinatorial problems are, geometric and numerical problems. So so there should be algorithms for sorting. The very first class, if you recall, I gave you an example, right? List about 3 algorithms, 3 to 5 algorithms, right? For sorting, and some of you have submitted that. Same thing for search, okay? The trick is, I call this like this is your toolkit, right? If you know these algorithms, depending on the context of the problem, you can apply one of those algorithms and then solve the problem efficiently. Okay. So those are different algorithms. Now, data structures, what are the data structures that we use? In your basic programming language, you learned about arrays. Have you done linked lists in your programming language assignments? Show of hands, I can only see Jntuk Kakinada image here. Okay, so you're all familiar with linked lists. Okay, good. String processing, have you done string processing? Okay, good. Have you implemented stacks? See, all of these are pretty straightforward, right? You learned about this concept, so that's the same thing we learn here. Only thing is we learn it in a slightly different perspective. Okay, so that is the outline of what this course is all about. You will learn all the algorithms related to sorting, searching, and all of this stuff. And then you will implement those algorithms using data structures like these. Okay. Now in the process of doing that, we will analyze what you have done for time efficiency and space efficiency. Okay. Okay. Chakravarti garu, you want to add anything in terms of summary? The way we kind of did the class last time was after I finish a chapter, you used to summarize that. You want to do that or we are good? Okay. Chakravarti garu unnaru leda classroom lo. But we generally used to summarize. Okay, great. So that's it. So you learn about those algorithms, you learn about time efficiency, space efficiency, and you use those data structures. Okay. Principal H&M, let me unmute them. Sometimes the unmute works, sometimes it doesn't work. Okay. Arrangement of data in particular order. What do you mean by that? From principal underscore HM, they put something called arrange. What do you mean by that is probably in terms of sorting, maybe. Maybe you're defining sorting to say that arrangement of data in particular order. That is true. I agree with you on that. Okay, so let me go back to my thing here. Let me see if I can open up another slide deck here to go to chapter. Bear with me. I'm going to my folder here. Give me 1 second, Andy. Okay. Let me start the second chapter. I don't know if I'll be able to finish it, but we will go through that. It's still a little bit theoretical, but we'll do an assignment at the end of second chapter. Okay. I'm sharing a PowerPoint here. Okay. If you are not seeing it, you let me know. Let me put it in a presentation mode here. Okay. So we'll talk a little bit about the correctness, time efficiency, space efficiency, and optimization. Okay. So what do we mean by time efficiency, right? So time efficiency is analyzed by determining the number of repetitions of the basic operation as a function of the input size. Okay, so you have certain input that you're getting, you know the size of the input. Let's say if I'm saying sorting 100 names, I know the size of the input is 100 names, right? So that is the input, and then we see how many times you have to repeat the process, right? And then you have the basic operation, which means the operation that contributes most towards the running time of the algorithm. Okay. Now we are getting into some formulas, equations, and all that. Students, I must warn you. The notation, don't get hung up. Correct. Thank you, Kitty. Don't get hung up on the notation there. Okay. I'm not a big fan of all the notations and all that. I'll introduce some theory, but I'm more a practical guy. Okay. So, but we learn a little bit of theory. Okay. So how do you see the equation there? So T is for running time, right? We always say time. We are talking about time efficiency. And then N is the input size. How many elements are there? Okay. And C is the execution time. The op is operation, right? And then depending on how many times you execute that times C gives you the total time, correct? If I have to repeat something, let's say each time I do it, it takes 2 seconds. And if I have to do it 30 times, 30 times 2. The C, small c is 2 seconds and capital C is 30. 30 times. So that's how you calculate that. Okay. Okay, here are some examples, right? Very well given example, well narrated examples here. So you have a problem like searching for a key in a list of n items. Okay, so what is the input size there? The input size is n items because it's saying there, right? And what are you doing there? Basic operation, key comparison, right? If I give 100 names, I say search for a name John Doe, right? So John Doe becomes my key. So I'll have something called I'll write a for loop, right? For the first row there, for I equal to 1 to, or for I equal to 0, I less than what, 99, right? Okay, then in open parenthesis, you say key comparison, your search string, and then the array, assuming you stored the names in an array, you say A0, right? If match found, you come out of that. If match not found, iterate through the loop, right? That is the key comparison. Look at matrices. So when you have we call it matrix, right? Here we call it matrix. So multiplication of two matrices. Okay. So if I have matrix is nothing but a table, right? So if I have like an n-dimensional table, right? Or the total number of elements. If I have a 3 by 3 matrix and a 2 by 2 matrix, right? So that is total of 13 elements there. Okay, it could be dimensions. 3 by 3 is 9 plus 2 by 2 is 4. 9 plus 4 is 13. And what are we doing there? We are multiplying two numbers. Okay, so when we talk about time and space measurements here, if I go back to the slide here, 1 second. That's what we are doing. The way we are analyzing time efficiency is that. So what could be a potential exam question here? The exam question, if I may give you, is I'll take some practical problem. Let us say I would say that here is a list of students and I want to calculate who got the maximum GPA, right? So I'll give you something like that. Say, okay, in this problem, what is the input size measure and what is the basic operation? So you should be able to tell me that when I give you that practical problem. Okay. Let me go back here. Okay. Now, how do we come up with the best case, average case, and the worst case, right? So there are some worst case. For example, remember I gave you an example where I said I want to search for a name in a string of 100, and my worst case would be it could be the last row of the array, right? Last element of the array. That is the worst case. Best could be the number one, the very first element of the array, right? So you have the best and the worst cases, and then the average. Okay. Averages, of course, we know how to calculate averages, right? So it is, remember, it's not the average, the worst and best case. There are some ways of coming up with the averages. Okay. And the way you come up with averages is you use random variables, probability theory. Okay. So if you know the probability distribution of the inputs, then you would be able to calculate the average cases. Now, let me ask you, if you remember basic probability. Chakravarti garu is back. Let me unmute him. Okay. Chakravarti garu, meeku probability gurtunda inka? I don't know about Chakravarti garu, but I can tell you that I have to share an interesting story, right? This normal distributions, binomial distribution, and all that probability stuff, I have a big phobia. Okay. I have such a big phobia. I must share with you this very personal story. You know, in India, to get into these engineering colleges, you have to go through a competitive exam, right? So for my MTech, we had to do a competitive exam in Osmania University, where there were like 3 or 4 seats in the open system and things like that. And I used to be good in math, but I left off the 2 or 3 probability questions that they gave in the exam. Because if you answer it wrong, you lose half a point. And you know, the admissions are based on fraction of points, right? I had such phobia for that. Even though I knew the answers, I let it go. So when we come to the same thing in data structures and algorithms, when we get into the distributions, I'm going to plead ignorance, or I'll say you go figure it out, or I'll rely on some of our expert staff here to help me with those things. Okay. Let me continue. Here is a sequential search. Wow, now we are getting into interesting stuff, right? I get super excited about these things. So what are we doing here? You are doing an algorithm. You're searching for a given value in a given array by a sequential search. Okay, so you have a 0 to n minus 1, that is n element array, and you're searching for a value k. Okay, and then the output is the index of the first element of a that matches k, or minus 1 if there are no matching elements. Okay, you all understand the problem there? Put it in chat if somebody does not understand, okay? Okay, I don't see anyone putting it in chat. I assume you all understand. It's trivial, right? So how do you solve that problem? Remember, first you make I equal to z, you assign 0. Remember, initialize your variables, correct? The rule, golden rule, right? Basic best practices guide would tell you, initialize all your variables, okay? Now you have to iterate through the loop. We already said it's an array, right? So you have to say while I less than n, okay? And a of I not equal to k. So you keep going through the loop, correct? Now, while you go through the loop, if I is less than n, return I, right? Else return minus 1. Fairly simple, right? Is there anyone who does not understand that algorithm? So what is the best case? What is the worst case here? What is the value of the worst case? Who wants to put it in chat for me? Somebody can type. To help you with that, I'll go back here. Maximum over inputs of size n, right? So the worst case should be, what is the worst case? Is the worst case n here? Yes or no? Nth element. Thank you, Chakravarti garu. What is the best case? Order of n, correct. SVECW, please put it, I will put that here, 1 second. Worst case from SVECW. SVECW said worst case is order of n. That's the correct way, okay, perfect. Order of 1 is the best case. Okay, according to SV, perfect. And then what is the average case? Order of n by 2. So you just took a linear normal distribution, right? You have to figure that out. That average case, how is it as simple because it's an array? You're just assuming it's n by 2, right? Order of n is what for average? Or is it SVCW? Can you please everyone? Akkada send to label, there's a send to label. Next to it, there's a drop down. You select everyone and type your answer. Then it will be shown to everyone. Right now, what you're typing, only I can see. Next to send to label in the chat window, in the drop down, you select everyone and type that. There you go. You got it. Perfect. So is that the worst case or best case or average case you're talking about? Type that. Oh, that is the best case. Got it. Yeah. We are talking about, no, the best case is order of one, right? It's not even order. It's really one, right? Average and worst case. Okay, got it. Okay. So Chakravarti Garu said average is n by 2. And you are saying average is also n. Students, I want you to follow this carefully, okay? So I do not know who is typing from SVECW. Is it a faculty member or is it a student? Can you type whether it's faculty? Please state your name. SVECW. SVECW. Let's see. Yeah, there is no static. If you are on video, by all means, show your video. I don't see your video. But you can see here how I asked what the average is. Somebody said n, somebody said n by 2. So I do not know who is correct. Let me put it that way. I would think it's n by 2 in this case. That is what I would think. But it's not a big deal, okay? Whether n by 2 is correct or n is correct, we can figure it out later. But you can see how different learned people have different opinions on that, right? If you do some mathematical analysis, the correct way of really answering average is if you know the distribution. That's why probability becomes important for average. If you know the distribution of the data, then you would be able to correctly answer whether it's of the order of n or it's order of n by 2. But I think it is n by 2 in this case. Okay, let me move on. Correct. From 1 to n. So when it's all random, then you apply something like sample space, right? Sample space, you get into the concepts of sample space and the value that you're looking for, right? And you do that probability theory there. I think that probability theory analysis would lead you to n by 2 in this case, if I remember my basic probability right. Okay, or we'll see here. Okay, so then we get into some slide here. Okay, now we got it. Okay. So now we get into some formulas, right? How do you count? Okay, so you get into some kind of a mathematical. We learned these things when we did the permutations and combinations class, right? Some kind of a formula you come up with. Again, I'm not paying attention to the formula here, but there are some mathematical ways of coming to those things. We'll analyze them systematically later. I'm just setting the stage for you there. Okay, so you can see here the order of growth within a constant multiple as n goes to infinity. Somebody is talking now. Okay, and then you can see a couple of other variations of that, right? How much faster will algorithm run on a computer that is twice as fast? Somebody's trying to talk. Somebody wants to talk. I can unmute them. No. Okay, got it. Okay, so so when you have, just because a computer is twice as fast, does it mean, what it basically means, does it mean the algorithm also will run twice as fast? Not necessarily, by the way, right? It goes back to how the system has been architected, the operating system design, and so on. Similarly, how much longer does it take to solve a problem of double input size? If the input doubles, would the problem take twice as much time? Again, not necessarily. There's, the correlations are based on some probability distributions. Okay, as you can see here, this becomes very important for you to look at this table here. Okay, most of the algorithms, when you analyze, you say if it's or remember somebody typed order of n, O of n. When we talk about algorithms, we typically type O of n or O of log 2n, right? N log 2n, n squared, n cubed, 2 raised to n, and n factorial. Okay, so whenever we come up with analysis of algorithms, you will see the order of one of these numbers. Got it? Now, which is so log 2 is smaller than n, right? So when you have an algorithm, one algorithm is order of n, and another algorithm is order of log 2 to n. Log 2 is binary, right? So I'm assuming students, you all remember your logarithms, right? So log means 2 raised to n is equal to 10. That's what we are trying to say here, right? If you have n equal to 10, 2 raised to 3.33 comes close to 10. Got it? And then of course n equal to 10 raised to 1. N log 2n is times 10. N squared is 100. The rest of it is pretty straightforward. N factorial, of course, is a huge number, right? So obviously when you have an algorithm which is then going from left to right, if you look at any of these numbers going from left to right, log 2n is more efficient in general. The next best is n, like that, going from left to right. Okay. So you can see here, now it gets into more theory. I understand some of these things you would be lost. Even I'll be lost when I look at some of these things. But the reason I'm showing you these things is these are the type of analysis that we'll be doing. Even though I would touch looking at the algorithms themselves, if they are efficient or not, mostly from business perspective. We'll do some analysis of the orders here. But you can see here where you ignore the constant factors and smaller input size. So when you have order of g raised to n, okay, one thing is they grow no faster than g to n. The other one is they grow at the same rate as n, meaning as the input size grows, what happens to the function? And then sometimes as the input size grows, what happens to the function? Do they grow at least as fast? So you can see here the dependency is on the whether the function grows at the same rate as input size. Let's say the function takes 10 seconds for an input of 10 numbers. Now if my input goes from 10 to 20, that is g of n, right? Would the function now take 20 seconds? Then it is growing at the rate of the input, right? At the same rate. That is the second sentence there. Okay. Sometimes even though increased from 10 to 20, the function when it took for 10 elements 10 seconds, whereas when you had 20 elements, it would take only 11 seconds. That means the function is growing slower than the input size. You understand how to read these things? Students, if you have any questions, raise your hand and put it in chat. How to read these three things here. So the G represents the input size, right? So as the input size grows, what happens to the function is what we are seeing. They can grow together at the same rate, or the functions can grow no faster than the input size, or they can grow at least. Meaning there are cases where you increase the input size from 10 to 20. So for 10 element, the function was taking 10 seconds. For 20, it could take 30 seconds. That means it's growing faster than the input size. So that means obviously there's a cutoff point where you will actually get point of diminishing returns. So these are the kind of things that we'll analyze too. Okay. Okay. So they use some notation because you should know how to graph, right? I'm assuming all of you are familiar with drawing graphs, or you use graphic calculators. This basically shows how as the G grows, the T would grow. G is the input size, right? And then T is that one. So you'll typically graph them. Again, in my class, I can assure you I won't make you draw any of these things because I'm more of a practitioner. Okay. Okay. Any questions, comments until now? Is it too theoretical for you? Okay. Bear with me for some more time. Okay. We'll get the theory out of the way and then we'll get into fun stuff of writing algorithms. Okay. So then he's giving some definitions, right? This mathematical notation. You're saying f of n, that is the function that you're performing. If the order of growth of fn is less than the order of growth of gn. Okay, that means it is less than or equal to. So you'll always see fn is less than or equal to c of gn for every n which is greater than or equal to 0. Okay. So how did he come up with 10n is of the order of n squared? Can somebody explain to me this particular example? 10n is of the order of n squared. Faculty members are welcome to explain that. It's not intuitive, right? Any faculty member? Chakravarti garu, you want to take a stab at it? Or Vasavi? Why do we say 10n when you have 10n? We are saying it's of the order of n squared. Is somebody there to type? Or it's not really very intuitive. Okay, why don't we do like this? Why don't you think about it? Oh, so 10n should be order of n, right? You're right. So why did he say it's order of n squared? Don't you think it's incorrect? So n squared, I do not know how to put a subscript, but 2 is for n squared, okay? So 10n is really, remember we are right, ignoring the constant. When you see n there, it's order of n. Same thing, 5n plus 20, ignoring the constant, you see the factor n there, so it's order of n again. Okay, so that's a typo. Okay, so you have some mathematical notations here which I'll ignore for now because those things don't mean anything for us unless you are a mathematician. Okay, now the reason I'm showing you these things is, right, the people who are involved in data structures and algorithms, especially algorithms, okay? But the reality today, I mean, this is what is important for students, right? The reality is in the industry, do you think we are measuring it like this? Are we doing any mathematical analysis like this for the algorithm that millions and millions of programmers are writing code? The answer is no, a big no. Okay. Nobody is going and testing your algorithms, whether they are super efficient or not like this. Okay. As long as you're reasonably good in algorithms, okay, it is good enough. And they can always how much time a particular algorithm takes depending on the type of data. Based on that, like an average programmer, nobody, okay, Chakravarti put an interesting statement. If n greater than 10, then it is correct. Which one you're talking about in the previous slide? Correct. Chakravarti made a good point there. He said if n is greater than 10, then it is correct. Possible because the reason, remember, he said if the constant is greater than or equal to 10, then all of a sudden 10 times 10 is 100, right? So in that case, then 100 is equal to 10 squared, correct? Got it? You're right. Well, your analysis is correct, Andy. Both SV, CW, and Chakravarti garu. Absolutely. Okay. So you can see we are getting into like limits and this kind of mathematical analysis. Okay. It's all fascinating from theoretical viewpoint. But what you would know as we go along is mathematical analysis. Some of the techniques, like when you go interview, right? Like for example, there are some interview questions. I know that. I mean, I'll share some examples as we go along. That, for example, my son at Berkeley, when he goes and interviews with all these Microsofts and LinkedIn's and Ubers and all that, right? They do test those kids on algorithms, mostly search and sort and things like that. Hey, what type of an algorithm you would use here? They're not asking them to do the mathematical analysis of it, but in general, even though the mathematics is there behind this efficient hash algorithms, right? Does it know when to use hashing, when to use indexing, right? What type of searches he would perform, when would he use binary search? So those are the kinds of knowledge that they're looking for. But they would never ask them to say, tell me if this is of the order of n or is it of the order of log 2n or n squared, whatever, right? But we'll come to this. Just wanted to show this mathematical stuff too. Okay. Now again, who will remember all of these things? At least I won't, right? You can see that all logarithmic functions belong to the same class called log of n. No matter what the algorithm's base is, logarithm's base is a greater than 1 is. So they just classify them as log of n. Okay. Okay. This is the equation, if you can remember, right? Last one, order of log n is less than order of n raised to a for a given subscript a greater than 0, right? It's kind of obvious, right? Remember at the table that I showed you, they have theorized the table into this one, the last step. Log n is always less time than order of n, and then order of a raised to n is greater than order of n, and then n factorial and n raised to n. all of those things are, you go from left to right, it becomes worse and worse in terms of time complexity. Okay, all the things that you put in chat are all correct. I agree. Okay, but I know that we have lost 80% of the students in this mathematical stuff, right? I'm almost finished with this. Okay. Again, this shows here 1 log n log n squared n cubed 2 raised to n factorial. Okay, and that is the order in which most of the algorithm analysis they fall into this one. Okay, how you compute that is what that all that mathematical theory was. Okay, having said that, okay, what is n here? It shows here, right? How do you do that, right? When I give you an exam question to come up with those orders, you should know what n is and so on, right? So you say parameter n indicates input size. What is the basic operation, right? You base all of your analysis on basic operation. Okay, and then you have to determine worst, average, and best cases. Okay, and then you should have some kind of a summation to show how many times the basic operation is executed. Okay, and then you can simplify that using some formulas that he gives. Okay, again, I know it's theory. When we start doing it, you will have fun. Now, this is again some kind of a high school algebra learned, right? Summation and all that. Believe me, I don't remember any of those things. I don't even know what sine and cosines are. But I trust you as we go through this, the students would be able to figure all these things out. Okay. Okay. Let me look at the time. How are we doing on time, Chakravarti garu? I'm supposed to end at 12:40, right? Time now is 12:30 for you. So what I will do is I will introduce this algorithm and give you some assignment. Okay, great. So we are doing good. It's okay. You may. Okay. Now, class is up to 12:40. So time now is for you 12:30. Okay. Okay. Great. We still have 10 minutes. Why don't I do like this? I'll cover some feedback from some of you. Okay. And then I'll post it in the community right after the class. So here is an algorithm, right? Maximum element of A 0 to n minus 1. Determine the value of the largest element in a given array. So you have n numbers. The output, the value of the largest element in A. So there's a way of calculating that, right? He shows the algorithm there, pretty straightforward. Even a high school kid can do that. Okay. Then you have unique elements. Determine whether all the elements in a given array are distinct. Wow, that's interesting, right? Returns true if all elements are distinct and false otherwise. So how would you do that, right? So there's a for loop he has given. I'm not explaining to you the algorithm because I want you to have some fun executing them, okay? So example 1 is you're finding maximum element. Example 2 is if they're all unique, okay? Example 3, matrix multiplication. Multiple loops, right? Okay. I don't even know Gaussian elimination, so I will skip that. I'll skip it because I forgot all my math. Let me be honest with you. I can barely do algebra, you know. Okay, counting binary digits. Wow, this is interesting, right? How you count I'm assuming you all know the binary and hexadecimal notation and all that. That's one of the fundamental things that we learn in computer science 101, right? So given a number, how many binary digits are there? Like if I say value of 16, decimal 16, how many binary digits do I need to represent that? Quick. You need 5? Why do I need 5? Is it 4 or 5? Remember our thing starts from 0, right? 4, correct. Yep, 2 raised to 4, right? Is 16. Okay, so these are some algorithms that are there. So let's see what else is there here. Okay, now you have to, for fun, since we are going to be learning all about algorithms here, right? I want you to, I'll put the slides. The algorithm is written here, but I want students to practice these algorithms, okay? They are very interesting algorithms. When you practice them, I also want you to see, I mean, they have given one way of showing it, right? If you come up with a different way of doing the same thing, let's take this example of unique elements, right? He did it for I equal to 0 to n minus 2. If you didn't see it, probably you'll do it for I equal to 0 to n, right? So you execute these algorithms and see what insights you gain. And next class when we meet, you share with us your insights, right? You understand? Okay, I will stop here instead of rushing through the rest of the slides. Let me ask for some feedback from faculty members. And let me go one at a time, okay? I'll unmute principal underscore HM. If your audio is working, you can talk. Is there a faculty member in the room? If so, you can tell me how are the students taking it so far? Is it too much, too little, too slow, too fast?
Yes, sir. Good afternoon. I am Dharmaya, faculty of IT class. It's very good, sir. We are learning from world-class design and analysis of algorithm subject evaluation. Today is very interesting, sir, compared to last 2 classes.
Excellent. Last 2 were just a warm-up. I wanted to get a feel for
Yes,
students. Okay,
yes,
good.
sir. Today is
Excellent.
very
Thank you.
Thank you, sir.
Now the trick is to make them work, right? They have to execute this algorithm. So that is what students, the more you cooperate with me, the more fun we'll have, okay? I have a lot of stories to share with you on these things. Okay, great. I think generally it's going okay. Okay, I'm getting static. You can put it in chat. Okay. GIET, I want to give an opportunity to all of them to say hello. I'm getting a lot of static in GIET, so you can put it in chat. JNTUV, I know they are generally their auditorium, they have so many students. If their video is on, we can see that. See, always, it's always
We
like,
comfort in your class, sir.
okay, excellent. And what happens if let me ask you a tough question then. What if I speed up my lectures? Or is this a comfortable pace for you? Okay, so so I can actually even speed up, but right now we'll go at this pace, okay? I want you to show me some proof that you are learning, then I can speed up. Okay, so next task is, before we wrap up, have you all signed up in the community? Students and faculty. I have not checked. Okay, I'm going to go verify that because right after this class in the next 10 minutes, I will be uploading the PowerPoints. And the assignment for you is those examples that I showed you, go execute them in any language that you like, whether it's C or C++ or Java. And then I'm going to pick on some students to share their code next class. Okay. And then we'll analyze them from algorithmic viewpoint. Okay, great. That's it for today. I will see you Wednesday, Chakravarti garu. I don't know whether he's there or not. Wednesday is 23rd my time. That will be 24th. Do you have class on 24th, which is Christmas Eve?
25th. Yes, sir.
Yeah.
Better.
Avunu, 24th we have class kada. Okay. Perfect. Okay. 24th holiday na meeku. Oh my God. See that? Let's
షెడ్యూల్ ఫాలో కూడా తెలుసు ఎట్లా షెడ్యూల్ వేసారని
డేస్ లో కూడా టీచ్ చేస్తాను. ఇంతకీ okay, so they said